Well, that was exciting. Sorry I had an inadvertent additional intro there. Good afternoon or evening, whatever it may be where you live, and welcome to SpaceWeek Live with me, Raw Space, on this Sunday, February 13th, 2022. It was a roller coaster of a week. We had some big ups and some big downs, so let's get into it. First, let's start with our Webb update. Okay, wow, sorry about that. I have some button issues here. So, the James Webb Space Telescope has seen its first star. In fact, it saw it 18 times. What we see here is a mosaic of the same star seen with the James Webb Space Telescope's 18 primary mirror segments. You know that large hexagonal gold mirror? Well, it has 18 segments. Each of those segments detected this one particular star that they were using as a target. And what we see here is a mosaic of those images. If we move on to the next, we can see here the different primary mirror segments that corresponded with each of those little blips, and as well as the 3 stars on either side, which represent the images from the wings of the telescope, which are the parts of the primary mirror that folded out during the deployment process. So what we see here is only a section of the overall image, which totaled about 56 gigabytes of data, over 1,000 images. And as they searched an area about the size of the moon for this star, to begin the process of aligning and calibrating the telescope. And they actually did a really good job they got a good cluster on their first attempt. Now, there are some people criticizing, well, some people, meaning internet trolls, criticizing, oh gosh, it looks terrible, I could take a better photo with my whatever. But the point is, this is the very first image in a 4-month-long process of calibrating and configuring the telescope. And so this was not intended to look pretty or provide any useful scientific data. This is purely an engineering image for the purpose of ensuring that they are, in fact, getting information. Well, they're getting reflections from all of the primary mirror segments, and where they are located. So what they will do now is they'll begin the process of taking those 18 points and bringing them together into a single focused image of the target star. And I'm not sure how long that will take, but again, it's going to be a total of about 4 months that it's going to take them to complete the calibration of the telescope. So this is not just like pointing your, celestron into the sky and looking at a target. I mean, this is a very complex instrument, and we should feel lucky that we get this, sort of play-by-play, behind-the-scenes look at the process of commissioning the instrument, because in the old days we would have gotten maybe the final product, but we wouldn't have been privy to all of the interim steps that are required, and it's the interim steps which are essential in order to get to the final product. So anyway, during that same image taking session, they also took a selfie of the primary mirror. So the images from the photons from outer space, from stars and whatnot, they strike the primary mirror, and then they bounce up to the secondary mirror, which is this parabolic reflecting mirror that is mounted on the tripod, and then that bounces it back into the hole in the center of the primary mirror where the receiving instruments are, the near cam, the near infrared camera, and the other receiving instruments on the telescope. So one of the cameras, it's primarily an engineering camera, is designed to take to receive an image of the primary mirror that is being reflected off of the secondary mirror, and that's for the purposes of again, for the purposes of checking the condition of the mirror as well as aligning the mirror segments. And the reason why there's one hex mirror segment that is illuminated is because it was pointed at a bright star, whereas the other ones are not quite. So again, pretty cool that it can take a picture of itself, but blurry though it may be, it served its engineering purposes, and everything they've received thus far is great. They assure us that, and this is a common issue with scientific missions, is that a lot of times the data they receive is useful, either in terms of the deployment of the craft or the calibration or for scientific purposes, even though to the general uneducated public, such as you or me, it might not look like much. But rest assured that it is doing great, and it is well on its way to being fully deployed. So last week, I don't actually remember if I mentioned the Starlink satellites that I don't remember which day the news broke of the Starlink satellites that were deorbiting. But so on February 3rd, there was a Starlink launch. And this is, let's see, 3 minutes. Let me just play this. Okay, so on February 3rd, there was a Starlink launch from Florida. The day after, on February 4th, Earth was hit with what's called a geomagnetic storm. And the geo just means it's happening at Earth, but the storm is coming from the sun. Basically, what a geomagnetic storm is when there's a change in the solar wind, or the flow of particles coming from the sun, typically as a result of a coronal mass ejection or some other more complicated solar processes that I won't really get into here. But basically, when there's a change or an intense blast of solar particles, ionized solar particles coming from the sun, when those particles interact with our magnetosphere, the Earth's magnetic field that surrounds the planet because of our spinning iron core, it can it can change the shape of the magnetosphere, and it can impact the ionosphere, which is the upper regions of our atmosphere, and can result in atmospheric heating, the heating of the upper atmosphere. And by upper atmosphere, I don't mean high in the sky. I mean like low orbit. And so it actually excites the molecules in the upper atmosphere, causing the atmosphere to sort of puff out. And when that happens, so what happens when you heat something up? It expands. And so the atmosphere actually puffs out and creates extra drag on satellites that are in low Earth orbit, which I was not aware that this was a thing until I read about it just this past week. But it absolutely is a thing, and it's a danger for satellites in particularly low orbits. The lower the orbit, the more atmospheric drag it's going to experience, especially during geomagnetic storms when the atmosphere is being agitated. And so SpaceX, unlike pretty much all other launch providers, when they launched their Starlink satellites, because the Starlink satellites have the ability to raise their own orbits with their integrated krypton Hall effect ion thrusters, what SpaceX does as a responsibility measure to minimize the risk of creating extraorbital debris is they actually launch the Starlinks into a low orbit, and then they check them out. They run tests, they make sure the satellites are working, and if everything checks out, then they raise the Starlink satellites to their target orbits. And so most of the time, when a rocket upper stage deploys a satellite into its, deploys a satellite, it is then in its target orbit. But in the case of SpaceX, they deploy it low, and then they raise it up later using their ion engines. So because the Starlink satellites launched on February 3rd were still in their initial low orbit, when the geomagnetic storm hit, the satellites were not only subject to increased atmospheric drag, but also subject to increased ionizing radiation that leaked through the magnetosphere from the sun. I mean, that had been emitted by the sun. And SpaceX commanded the Starlink satellites to fly in safe mode, which basically means they fly edge on in the direction of their orbit in order to minimize their cross-section so that they experience the least amount of drag. Unfortunately, because they were flying in safe mode, they were unable to raise their orbits as they were supposed to, and 40 out of the 49 satellites that were launched ended up re-entering the Earth's atmosphere, which was a pretty big loss for SpaceX. I mean, the value of the satellites was maybe about between $10 and $20 million based on estimates, because they don't release their internal expenses. Plus, you consider 4/5 of the cost of the launch was wasted, but so that was on the 4th that they were first subject to the geomagnetic storm. On the 7th, 3 days later, space debris, a lot of space debris, was spotted over Puerto Rico, and credit for this goes to, what's the name? Let me get the name here. The Sociedad Astronomía del Caribe, the SAC, the Astronomical Society of the Caribbean in Puerto Rico. And so credit to them for this. So I will go ahead and play this. This is at 1.5 times speed, but here we see some orbital debris coming in. And this could be one satellite, because each of the Starlinks weighs, I think, about 500 pounds. It's pretty big. They're flat, but they're large, and so they have a lot of different parts to them. So, and here we have the big one. So this is a danger of, like, SpaceX, they really are trying to act responsibly in minimizing the reflectivity of their satellites and minimizing the risk for orbital debris. Let's say they deploy their Starlink sats and one of them is dead on arrival. If they deployed them directly into their target orbits, then that would just be a potential debris hazard. But deploying them into these low starting orbits, ensures that if there is a problem that's either detected or if they're just dead when they get deployed, they deorbit quickly, as we're seeing here. Unfortunately, these satellites were not defective, but they were victims of a geomagnetic storm. Now, geomagnetic storm, or variations in solar wind, are going to be increasing over the next few years because we're approaching the solar maximum. Maybe 2025-ish will be the solar maximum. So the sun operates on approximately 11-year cycles. And, so during solar minimum, there's less sunspots, there's less solar flares. During solar maximum, there are more of those things. And so this is going to be an increasing concern as time progresses. But hopefully the financial hit doesn't hurt them too much. Hopefully they're able to either predict, using maybe our L1 Lagrange point, detectors or whatever. Hopefully we're able to predict this space weather a little better. And or maybe I don't know, maybe it was predicted and they didn't change their launch date accordingly. I'm not sure. But in any case, RIP Starlinks. So some positive news. On Wednesday, there was an RS-25 developmental engine test fire from the NASA Stennis Space Center in Mississippi. So the RS-25 developmental engine is the successor to the it's the developmental version, the RS-25E, which is the successor to the legacy RS-25D engine, which served as the three main engines on the space shuttles. But the RS-25E is what they're currently developing, or testing in any case, and they will be flying on the Space Launch System in the future. So here, let me waiting. Okay, I didn't actually queue this one up to the start time. Okay, so the test was about 8 minutes long, 8 to 8.5 minutes long, which is the length of time that the SLS main engines will have to fire during the first stage of the Artemis missions. So here we go. And that goes on pretty much for 8 minutes. I didn't notice any gimbaling during the test, although I was also paying attention to the chat, so I could have missed it. But so usually during these tests, they gimbal the engines, meaning they wiggle them and to side and back and forth to simulate the gimbaling of the engines during the actual launch, which is how they control the ascent trajectory of the rocket. As well as with the RCS thrusters, but the test was successful, no issues, and see if we can get another shot of the engine. here's the guts of the engine. Here we go. And if you're not already aware, the RS-25, oh, there's flame out. The RS-25 burns hydrogen and oxygen like the Delta IV Heavy. So its the product of that reaction is water vapor, and a lot of it. But yeah, so it burns very cleanly, nice blue flame, and the engine did beautifully. Now, Thursday is when stuff really hit the fan, I guess you could say. Thursday was a busy day. But before we talk about Thursday, let's talk about Monday. So Astra did launch on Thursday, but as a precursor to that, let's revisit their launch attempt on Monday, when the launch was aborted at T0, even after the engine ignited, because of a, quote, minor telemetry issue, unquote. But let's check out that launch attempt.
10, 9, 8, 7, 6, 5, 4, 3. Ignition 1, 0. Abort.
So again, that was an automatic abort, and that was triggered by, which means that the rocket did exactly what it was supposed to do. It detected an anomalous condition out of acceptable ranges, and it shut down the launch before it could happen, which is, bravo for the rocket, putting a stop to the launch rather than and now, if this had been a solid rocket motor, or a solid propelled rocket rather than a throttleable, liquid propelled rocket, then once it's lit, and there's nothing you can do. It's going. but they can stop this launch before it gets off the ground, and because it detected an issue with the telemetry system of the rocket. However, on Thursday, we have they launched, well, successfully to start with. Let's check out the launch first of all, then we'll talk about what happened from there.
15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 0.
So it took off straight up from the pad, unlike the power slide we saw 2 launches ago with Astra. But
as well as the velocity and altitude of the vehicle.
Yep, and it looked beautiful up until the point where stage separation was supposed to happen, and that's when things went awry. So let's check this out, and then I'll rewind and we can take another look.
Our stage separation, and that was MECO, or main engine cutoff. That was fairing separation and stage separation. And you can see that the upper stage ether engine
running.
has lit.
Okay, so what the heck just happened there? Let's go back and take another look. All right, so MECO, which is main engine cutoff, is about to happen. I'm going to slow this down to half speed. And
Our stage separation.
boom. Okay, so there was a little jostle there, which I believe was main engine cutoff. Okay. Now, it's important to bear in mind that the Astra rocket is put together a little differently than most other rockets, and that is the entire second stage is contained within the payload fairing. We also see this with we also see this with Atlas rockets, like the Atlas V. So rather than stage separation happening and then the fairing deployment, the fairing jettison happening, like we see with SpaceX, the fairing has to get out of the way first with an Astra launch, and then the second stage can separate and ignite. And so what we see here is there's MECO, and then...
And that was MECO, or main engine cutoff.
Bonk. So what you're seeing there is the second stage of the rocket bonking against running into the top of the payload fairing, or the top of the fairing, because the fairing has not jettisoned. It has not come apart. And it was pointed out by someone else that, so you probably can't see my mouse, but you see that sort of rectangular silverish thing right at the top of where those two black bars meet. So just to the upper left of that is an L-shaped little doodad. That is a bracket that is holding the fairing halves together, and that did not become detached. I mean, it did not open up and separate the fairings as it was supposed to have. So we had MECO, the fairing did not come off, and then the rocket was just following a script. And so, interestingly, it did not detect that the fairing was still in the way. It released the second stage, which then bonked its head against the top of the fairing, and then a few seconds later, second engine kicks in. And when the engine bonk, and then when the second stage engine fires, boom! It the gas pressure from the engine exhaust blows the fairing off of the top of the rocket and causes the second stage to go tumbling off into oblivion, which we see here. But so not good. The 4 small sats that were on board were lost, and Astra will have a lot of work to do to rectify that design issue. But it mostly worked. Yeah? So hopefully better luck next time. They did have some other launches planned for this year, and unfortunately a few seconds of flipping like this, and they cut the feed back to the launch pad. I wish they had kept it on the rocket so that we could see it continue flipping. But yeah, so that sucks for Astra, but they're still doing good work, and even though their stock took a hit, I'm sure that the NASA spaceflight, so courtesy to NASAspaceflight.com for that footage, by the way. They were the official broadcaster for Astra. Though they didn't personally have a camera on the rocket, but in any case, they provided the broadcast. And I'm sure their live stream was blowing up with angry Russian investors, because for some reason the Russians seem heavily invested in Astra. But yeah, so rip Astra rocket, and better luck next time. Also on Thursday, a Soyuz OneWeb, a Soyuz 2.1A launched with 34 more OneWeb satellites for the OneWeb constellation. Let's check out that launch. And this is the replay of the launch. So we're not starting at T minus 15 as usual, because during the actual broadcast, oh my lord, the announcer or the commentator was talking over the entire thing, and we got no sound from the launch. So, but here I'm showing you sort of the executive summary after the fact.
Alpha et Delta fonctionnent nominalement.
Beautiful launch as always, and so there are now 428 OneWeb satellites orbiting the Earth. So also on Thursday, this was actually earlier in the day, so either very late Wednesday or early Thursday morning, SpaceX completed the stacking of the S-20 Starship on top of the B-4 Super Heavy booster, which is what we see here. And they used their new Starship lifting crane apparatus, which I'm not sure what the official name is, but that thing is awesome. Yeah, so Starship S-20, or SN-20 if you want to use the old naming convention, is fully stacked and 400 feet high. That is 95 feet taller than the Statue of Liberty and 37 feet taller than the Saturn V rocket. This is a monster. And the Super Heavy booster, once it's fully outfitted with Raptors, I don't think they have 27 Raptors on this booster. I don't know, maybe they do, but in any case, once it's fully outfitted and ready to go, we'll have way more thrust than anything that's ever been launched before. So as a follow-on to that, so they fully stacked it in the wee hours of Thursday, but then Thursday evening, Elon Musk gave a presentation. Every year or two he gives a big public address updating people on what's going on with Starship. And this was no different. He actually didn't provide a lot of new information. He made a lot of dad jokes and jokes about 42069 and things like that. But he didn't, and he talked a lot about sort of the broad, sweeping topic of why become a multiplanetary species. But that's kind of the same thing he's been talking about all along. He didn't actually provide a lot of specific information about the development of Starship, aside from the fact that they had reached the milestone of fully stacking the 420 boost, the 4/20 Starship plus booster. But he did say that they were working through some environmental approvals, and that they may do their orbital launch later this year. But he, again, short on specific details. People had a lot of insightful questions for him, sort of some of the usual suspects, Everyday Astronaut, and I think Space.com was in there, and even SpaceX-centric asked a question. But all in all, it was maybe a bit less of a substantive, like a bit less substance than we were hoping for, but nonetheless, it was good to get something, some information. Okay, so taking a look back at space history, this Thursday the 18th will mark the first anniversary of the Perseverance rover landing on Mars. So the Mars 2020 mission, of course, launched in July of 2020, but it landed in February the 18th of 2021. And ever since, Perseverance has been roving around on Mars, sending back data, which, by the way, I have been accumulating. I have a script that downloads the raw images from the Perseverance mission every day. I'm just not sure what to do with them, because they are raw images. They're not sort of the the grand mosaics that you're used to seeing, panoramic mosaics that you're used to seeing, because those take processing. Like, they take somebody at NASA stitching all the images together, color correcting them, making it look pretty, and then releasing it to the public. But these are like raw images, and so they're not very big, and there are a lot of them. But in any case, I do have those, that archive, and I'll figure out something to do with it at some point. Now, looking ahead to the schedule this week, later today we actually have a launch from India. Tonight, Sunday, February 13th at 7:29 p.m. Eastern, 029 UTC on the 14th, ISRO will launch PSLV C-52 with the EOS-4 satellite, also called RISAT-1A. It will use synthetic aperture radar, or SAR, to observe Earth's albedo or reflectance, soil moisture, vegetation, ocean currents, plus snow and ice coverage. So this Earth observation sat was delayed. The launch was delayed from last year, but it should be going up this Sunday. Today. Tomorrow, Monday, February 14th, at 11:25 p.m. Eastern, 0425 UTC on the 15th, a Soyuz 2.1A will launch from Baikonur with the Progress 80P cargo craft to the ISS. Wednesday the 16th, we have a full moon. If you want to go outside and do some moon gazing, with the fullest of fullness happening at the middle of the day, or in the middle of the day, for me, at 11:56 a.m. Eastern, 16:56 UTC. On Thursday, February 17th at 1:30 a.m. Eastern, 0630 UTC, Progress arrives at the ISS. It rendezvous and docks at the ISS using the automated Kurs docking system. I will be providing some late-night coverage of the rendezvous and docking for your viewing pleasure. And the timing is unfortunate, but these things happen. Then on Saturday, February 19th at 12:39 p.m. Eastern, 17:39 UTC, a Northrop Grumman Antares rocket will launch from Wallops Island, Virginia, with the Cygnus NG-17 cargo spacecraft to the ISS. So these are two ISS cargo launches in the same week, which is pretty cool, just a few days apart. Now, it arrives at the ISS the following Monday, February 21st, which I will cover in next week's episode. Next Sunday, February 20th, at 10 a.m. Eastern, 1500 UTC, I don't have, SpaceX launches another batch of Starlink satellites. Hopefully these do not suffer the same fate as the last one, which they shouldn't, because the chances of a geomagnetic storm happening during the fairly narrow window in which the Starlink sats are at their lowest orbital altitude is pretty slim. But nonetheless, I'm sure that they'll be taking extra care to ensure that they don't have a repeat of what happened with the last batch, where they lost 40 of 49 satellites. I'd like to take a moment to, so that is it for the coming week. I'd like to take a moment to thank and welcome our new channel members, Jacqueline, or asterisk, Jacqueline asterisk, and Yazata. I don't know if that's Japanese. Yazata. All right, so let's get to your questions. What have we got? This is from Friday Ray. What to do with all my Hubble coffee table books when Webb shines soon? Well, Hubble will always be, so I don't even know if there is an optical major space telescope on the horizon. I have no idea if there are plans for a future optical light wavelength telescope. But remember, Webb does not operate in the same part of the spectrum that Hubble did. Hubble was primarily an optical telescope. It could also see in the very near infrared, but Webb is solidly a infrared telescope. It goes up to about the color orange, but not higher than that, and down much lower than Hubble did. So we're not going to get, unless they shift the colors, which, I mean, it's normal to do false colorization of images in parts of the spectrum that we can't see, because guess what? Not only can we not see that part of the spectrum, but our monitors can't display it. So in order to visualize what's actually being detected, we have to adjust the colors. But I guess we shall see. I'm not even sure what we can expect to see from Webb, except that it will be scientifically spectacular. But it may not look as pretty as Hubble images, and so chances are that your coffee table book will still be a showcase of the premier optical images of deep space objects that is available for the foreseeable future, because I think it'll be a long time before we have another Hubble. Clifton Tibbetts. Raw space. Did they say what happened or the cause of loss of Astra? So I kind of covered that earlier. I'm not sure. I don't think that Astra has come forward with the root cause of why there, because there were potentially multiple things that happened, like the fairing didn't open, the rocket didn't prevent the deployment, the separation of the second stage, even though the fairing wasn't open. So there are maybe multiple failures or things that went wrong that led up to what we saw. But the physically what happened was the second stage is contained within the fairing. The fairing did not open the way it was supposed to. The second stage was separated from the first stage, which caused it to bump into the front of the fairing, or the top of the fairing. And then the second stage engine ignited on cue, as it was supposed to, except there was a fairing in the way. So when those exhaust gases filled the fairing, it blew it apart, just like most explosions are not just combustion; they're also hot. They're also rapid expansion of gases, and which is why, again, the old Armageddon analogy: you put a firecracker in your hand, you burn your hand. If you close your hand over it, you blow off your hand, because the expanding gases have nowhere to go, and so they cause violent. They cause a violent eruption of whatever container they're in. So that's pretty much what happened with Astra. But as far as the root cause of why those systems failed, why didn't the fairing open, why didn't these things detect that there was a problem and stop the deployment and the ignition of the second stage, that remains for the investigation by Astra to find out. Mark Desire, MVM Motovlog Music. Do you think that Roscosmos will ever pursue making a Soyuz booster reusable? Well, Soyuz will never be reusable, but as for whether Russia will develop a reusable rocket, that's certainly a possibility. They, Russians are famously pragmatic. They're a practical people, and if it is beneficial to their bottom line to make reusable rockets, then there would have to be a cost-benefit analysis of the cost savings of reusability versus the job creation of expendability. Like, if you can reuse a rocket, then that's less work that has to be done in order to make launches happen, which means less man hours of labor to produce those rockets. But in any case, I think that in the future, eventually they will, but I'm not personally aware of any projects currently underway. But then again, I don't keep terribly up to date on Roscosmos's endeavors. But as we shall see. Mark Desire, not sure if Soyuz can be redesigned to become usable. No, I mean, you can't really well, if you have a small rocket like Electron, you can put a parachute on the thing and splash it down in the ocean, or maybe catch it with a helicopter. But Soyuz is a medium-sized rocket. It's very robustly built. The thing is a tank. And yeah, no, a redesign of Soyuz would be, I think, more expensive than just designing a new rocket from scratch, from the ground up, to be reusable. Typically, it's more efficient, and you'll end up with a more streamlined, better system if you just start over. You know, I mean, the good thing is they have, you know, perhaps even more experience launching rockets than we do. So they have, you know, many decades of precedent to inform their potential future developments. Let's see. Yeah, chopsticks. That's right. The Starship lifter. That's what they call the chopsticks, because it starts wide and then it clamps down on the, well, it doesn't clamp down on it, but it you know, closes on either side of the Starship and then lifts it up and rotates it into position. But they're called the chopsticks, at least by the nerdles. I'm sorry, that was improper grammar. The nerdle over at Lab Padre, but I'm not sure what SpaceX actually calls them. So Mark Desire, 400 feet, is about 122 meters. The real YT. Cool. Are you going to show the launch for later today? Yes. Unless I state otherwise. I mean, if it's a Chinese launch, 95% of the time, there's not going to be a live stream. But or if it's a Russian military launch from Plesetsk Cosmodrome, most of the time there is not going to be live coverage. But for basically everything else, there will be a live stream. And so, yes, I will be bringing you the Indian launch later today, as well as all the other events that I mentioned in my calendar, which I will link now in the chat. And including the middle of the night one from 1 to 2:30 a.m. of the Rendezvous of Progress. Mark Desire might watch the Indian launch. That's good to hear. Although that's kind of late for you. That's so 7:29 p.m. That's 9, 10, 11, 12. That's like 1 in the morning for you. But if you're awake and if you make it, then we'll be glad to see you. Geraldine Braun, count me tuned in. Super Bowl doesn't interest me too much. Oh yes, it is the bowl. It is the day of the superb owls, as I say. But no, football doesn't interest me in the least, not even a little bit. So I will not be watching that later today. And I'm glad it didn't happen. I'm glad the Super Bowl didn't happen during my normal SpaceWeek broadcast time, or else half of y'all would be watching that. Let's see. Andrej says, I have a question. Do you have Zgape icons from us? I'm not sure what that means. The real YT. Did the Starlink problem affect you? Oh, okay. So I do have a Starlink dish, but it actually hasn't been... I feel bad because I have my Starlink service, which I'm paying for. I have the dish, but it actually hasn't been set up since late December because I got a new garage door. My old garage door had a big gap at the end that I ran the cable through to go out to the dish. The new door is new, and I don't really want to run the cable under that door for fear that I'll either damage the cable or, I mean, it's not going to damage the door, but I don't want to damage the cable, and because it's not replaceable. And so I actually haven't been using my Starlink internet connection for a number of weeks now. Shame on me. And because of that, I have pretty much decided that I want to cancel the service. I mean, I kind of would like to test it out at locations around town to see how far away I can use it. But based on the known cell sizes of these hexagonal cells that Starlink is apportioned into, or that Starlink service is apportioned into, I can only really reasonably expect it to work within about 10 miles of my house. And that doesn't get me far enough away to really do any good. I mean, within 10 miles of my house, I'm going to have a strong 5G cell signal anyway. So if I need data and I'm within 10 miles of my house, I can just tether to my cell phone. And there's no information at all about the much anticipated mobile Starlink, where you can mount it to your mobile home or whatever, and motor home, I should say, or truck, and like use it in different locations. You can transfer it to a different address. Sometimes you have to contact support for that, and the target address has to be in a Starlink available cell, but you can't just take it, like to the beach or to the mountains or whatever, because your service isn't going to be available there. Starlink itself may be available there, but your account is tied to a particular geographic region. And so I've been planning to cancel my Starlink service and save that money. But once I do so, I'm going to have a dish that is just a really big and fairly expensive paperweight, unless I can find somebody to buy it. But the problem is, anybody that buys it, so it's complicated. But there are actually a lot of people in this position. But I was, after all, a beta tester, or rather a user of the Starlink beta service. Not like I didn't need Starlink for my primary internet connection, which remains Google Fiber, land-based. But yeah, I will probably be getting rid of my dishy because even though it is cool and I support it, I don't need it where I currently live. I have reliable, fast internet through the ground, and the expense is becoming more difficult for me to justify. So, as far as the Starlink problem affecting me, it wouldn't have, because these are the Starlinks, the 40 out of the 49 Starlinks that deorbited were freshly launched, and they were not yet provisioned. They were not yet, because it takes them a while. It can take them weeks, even months, to get to their target orbits before they become active on the constellation. And so these were not Starlink sats that people were using. These were ones that were going to be put into use some time down the road. But okay, let's see. Raw Space Addict. What were the tiny fireflies in the Astra fairing at first stage burnout? From the burnout itself? See if I can pull up that video again. Okay. So here we have all right, let's make sure this is playback speed normal. Okay. All right. So here we have boof. So on the right side, you see the upper stage flipping. On the left side, you see the first stage looking up, and there are these little golden firefly thingies that that fly away. So there's no oxygen up there, or rather there's not enough oxygen to burn. There's just stray molecules of atmosphere, not actually atmosphere. And so this is not combusting material, but they may be glowing bits of it's not clear what those were, but it's probably, you know, glowing bits of stuff from the top of the first stage that was blasted by the second stage engine when it ignited. And yeah, it's not something that we should see on successful launches for sure. But it's not like fireplace ashes, you know, floating through the air, because there's no oxygen up there to combust. So it's unclear exactly what those bits of stuff were. Peter Corton's new member. Does NASA have enough bandwidth to get all the data from their missions on the Deep Space Network, or do they have to plan and prioritize all the time? So the Deep Space Network is a network of 3 facilities located at strategic positions around the globe, about 66 degrees separated from each other, I think. And they have really, well, they have multiple dishes, but their primary dish at each location is huge. These are big dishes. And they're designed for receiving very faint signals from spacecraft in the far reaches of the solar system, such as, you know, Voyager, et cetera, New Horizons, other planetary missions, the Mars missions, any interplanetary missions. The signals have to be received by the Deep Space Network. And so their positioning around the world ensures that at least one dish is always available for any given part of the sky, because the Earth, of course, is always spinning. Now, dish time on the Deep Space Network is not only very expensive, but it's very limited. And so the more missions we launch, the more load the Deep Space Network has to bear in terms of different signals they have to receive. And, you know, they're still receiving signals from Voyager. They're still receiving signals from Mars Curiosity, from the Mars the Mars orbiters, from Perseverance, from, you know, other missions that are out there. And they also receive data from the James Webb Space Telescope. You know what? I believe it is the DSN that receives the information from James Webb, because after all, it is in a fixed position, relatively fixed position, relative to the Earth and the Sun, as opposed to orbiting the Earth, you know. So yes, the DSN antenna dishes are, they have a pretty heavy workload. And that's going to be a problem if we have an increasing cadence of deep space missions, because there may come a time when there's not enough time bandwidth or you know, availability on the Deep Space Network to receive all the signals we need to receive. We may need to build more telescopes, which is a good thing, because the more receiving capability we have, the more we can send out there. But it's a great question. And I could be way off on this, but if I recall correctly, I believe that I have seen the number $40,000 per hour for Deep Space Network radar dish time, which is quite pricey, which is one of the reasons why SpaceX never designed the Starman launch to transmit video long term. You know, they transmitted video as long as they could, and then the batteries died, and then it was dead. Because if it had been a deep space mission, like Starman would be continuing to transmit, then it's the deep space network of telescopes which would have to receive those signals, which is very expensive, and so that was not necessary for their mission at all, and so they didn't do that. Tig, formerly known as Rayhoff, asks, is there any deadline for the ISS deorbit? Oh, well, that's been a question for a long time, and I saw a headline recently, within the past couple of weeks, that they actually plan to deorbit the ISS in the early 2030s, like 2031 or 2032, something like that. So that's the best info I have, is maybe in the early 2030s. But you know, I mean, they just got a brand new science module delivered up there on the Russian side, and you know, they have brand new solar panel additions that they've been adding. They added the IROSAs, they added two of the IROSAs previously, and more are going up soon. So you know, they're not done with ISS, but its days are kind of sort of numbered. But maybe 2031, 2032, something like that. Evgeny Myasnikov, I get that right on the third time. When can we see again the launch of Crew Dragon or Cargo Dragon? So if I if I look on the schedule here, crew. Oh, crewed spacecraft. Here we go. Axiom Space Mission 1. That's okay. That's coming up in late March, maybe. Starliner, tentatively scheduled for December, I guess. Now this website is not the be-all, end-all of launch schedules, but oh, Starliner 1. So the next Crew Dragon mission is not listed here, but that's okay. So I'm not actually sure when the next Crew Dragon mission is scheduled to go up. A quick Wikipedia search should yield the answer for you. There are a small army of very conscientious Wikipedia contributors who update it with mission information, cargo information, etc., etc. Let's see. Raw Space Addict. Nope, not far back enough. Before second stage release, not after fairing SEP. Okay, referring to the Fireflies. So, yeah, maybe there was an issue before even what I replayed for you. But rest assured that Astra will thoroughly investigate the event and hopefully ensure that those problems don't happen again to the best of their ability, which, of course, spaceflight is hard and no system is perfect, but we do what we can, and so will they. All right. So thank you all for coming. I appreciate it. I hope to see you later today for the ISRO launch. And until next time, keep it raw and take care. Bye-bye.
can't explain it